Okay, I've been asked about this question. We're in chapter 9.5. This is question 4 from the questions list there. A javelin with mass 800 grams is thrown out at an angle of inclination 40 degrees. It's released at a height of 1.45 meters with a speed of 28.5 meters per second. There's two things that we need to know. One, calculate the javelin's initial mechanical energy on release. Okay? And B, calculate the speed of the javelin as it hits the ground. So we'll have a bit of a look at that first of all. So in year 12, we talk about projectile motion, but we don't need year 12 stuff to try and answer this. This is a conservation of energy question. We're asked, what is the mechanical energy of the javelin as it is released? In year 11 physics, we say mechanical energy is the combination of kinetic energy and gravitational potential energy. So we know that the javelin here is 1.45 meters above the ground. We know the mass of the javelin. So we've got the gravitational potential energy at the start of the story. We know the velocity of the javelin as it's released, so we've got the kinetic energy of the javelin at the start of the story. Okay, so 336 joules. So that bit we've got. We're comfortable with that bit? Okay, part B of the question, calculate the speed of the javelin as it hits the ground. When we release the javelin, it has mechanical energy equal to EK plus EP. When it hits the ground, we have mechanical energy equal to EK only. There is no potential energy when it hits the ground. Okay, so all we've got to do now is recognize that according to the conservation law of energy, the energy with the javelin as it's released is with the javelin all the way through the journey until it hits the ground. And then the energy goes into the earth by changing the shape of the earth as it drives a hole in, and there's sound and there's all sorts of fun stuff going on. So to know the velocity as it hits the ground, we just say, so that EK final, okay? Do you get the idea? And so the answer there, 28.98 meters per second. So I've been asked to look at 9.6 question 1. A 1,610 kilogram car accelerates from 0 to 100 kilometers an hour in 5.5 seconds. Calculate the average power output over this time. So the work done divided by the time. What was the work done? It's giving it when it has no kinetic energy, now it has kinetic energy. So we find out the added kinetic energy to the vehicle divided by the 5.5 seconds, and we should get the power output. Okay, good.